All right, here's the situation. This question says, using law of sines, a weight of 1,000 pounds is suspended from two cables. What are the tensions in the two cables at 25 degrees and 40 degrees? You've used law of sine, not vectors. I have to use vectors to set up the triangle for law of sine, so I don't know. So here's the horizontal line. Here are the two cables. And by the way, this figure is not drawn to scale. This one is 40 degrees. This one is 25 degrees. And 1,000 pounds is hanging from it. And it's suspended, meaning it's not moving up or down, it's just hanging from it. So I can redraw the horizontal here, and these are parallel. The real horizontal on this one I've drawn. So that is 25 degrees, opposite interior angles, and this is 40 degrees. Opposite interior angles, when you draw a line between two parallel lines, those angles are equal. So now I'm going to take the vectors. The 1,000 is straight up and down. That's the 1,000. I'll call these, by the way, this is the tension on wire 1, the tension on wire 2, or cable 2. So now I'm going to take T2 here and put it right here. This is T2, figure not drawn to scale. And then this is 25 degrees, the angle it makes with the horizontal. This is T1, and notice it goes down like this. There's T1. And let me get rid of this little extra portion here because of my terrible art skills. And the angle it makes with the horizontal is 40 degrees. So now I've got a triangle. And how can I find these angles inside the triangle? Well, this vertical line makes an angle of 90 degrees with the horizontal, so these two angles equal 90. So the interior triangle is 90 minus 40, that's 50 degrees there. And here, 90 minus 25, which is 65 degrees. And then the third angle of the triangle, 180 minus 50 minus 65, is also 65 degrees. And I can set up law of sines. 1,000 over sine 65 equals T1 over sine 65 equals T2 over sine of 50. It's the side divided by the side of the angle opposite it. Those are all in degrees, by the way. Degrees, degrees, degrees. So T1, it's 1,000 over sine 65 equals T1 over sine 65 degrees. T1 equals 1,000 pounds. It's got to be equal to that number. And I can cross multiply here. T2 times sine 65 degrees equals 1,000 times sine 50 degrees. And if I divide both sides by sine of 65 degrees, that's T1, or T2 rather, equals 1,000 sine of 50 degrees over sine of 65 degrees. That's the exact answer. That equals approximately, I just threw it into Desmos, 845.236 or 845.2, 845.2, maybe just write 845. It's approximate, 845.2. So T1 is 1,000 pounds. T2 is 845 or 845.2 pounds, however you want to round it.